All right, for number one, simplify the radical and then see if you can add those two numbers. So I like that number under the radical sign. Why? It's a perfect square. What is the square root of 144? 12. And then since it's negative, we also can make the answer I. And then our radical sign is gone. And then that's it. We can't add those two because they're not like terms. So just leave it. 7 plus 12i. For number two, similar problem. We have a radical that we have to simplify first and then see what it looks like. So the 3 just stays 3 for now. And then 50, I like to make it 25 times 2. I like that number 25 because another perfect square, right? So the square root of 25 is 5, so the 5 will come out front. And since there's a negative sign, the I comes out in front. We still had a number left, so we have to leave it under the radical sign. These aren't like terms, so I can't add those either. Now remember, if there's more than one number left under the radical sign, I would multiply those. If there's another number out front, like 2 times this square root of negative 50, I'd have to take that 5 and multiply it by that 2. Okay? So if there's stuff out front, multiply, not the plus here. The 3 plus just stays 3 plus. But if there was a number, like I said, in front of the radical, like I said, 2 times it or 3 times it, whatever. Sometimes we add those. We're not supposed to. We're supposed to multiply those. All right, number 3 and 4. Every year, I get kids that miss these because we've been doing a lot of foiling, so they try to foil this. Do we try to foil this type of problem? No. Let's try to make sure we don't foil tomorrow on a subtraction or addition. Okay? So Hassa, what do I get when I subtract?
I got 3 plus 6, 5.
Very good. 8 minus 5 is 3, and negative 3 minus a negative 9i is like negative 3 plus 9i, which is plus 6i. Okay? So don't make it a harder problem. If you foil it, it takes more time, right? Makes it a little tougher. So don't foil number 3 or 4 tomorrow. Okay, they're going to look very similar. I'm just changing up numbers. I'm not trying to trick you. Okay? So, Tasha, what do you get when you add those? Very good. 5 plus 6 is 11, and 2 plus a negative 7 is a negative 5. Question? So should we miss any of the first 4? No, we shouldn't. All right? I'm expecting good grades. Getting rid of lots of stickers tomorrow. Okay? Some of us struggled a little bit the last couple weeks with the factoring. Here's a quiz that you can help maybe pull up your sum of the grade for your overall grade. Okay? All right, number 5. This is multiplication. There's nothing between my 2 parentheses. So that means you multiply them. So we just multiply the 2 together. Now you can multiply anything. They don't have to be like terms, even though they are like terms. But it's just negative 6 I squared. Just like if they were x's, it would be negative 6x squared, right? Now, remember, we've talked about this all week. The square root of negative 1 was I, but also I squared equals what? Negative 1, right? We've been talking about that. So I have that situation, okay? So usually we don't write this out, but I'm just showing you that's what that means, right? So the answer is 6. What I like to do is when I see the I squared, I just cancel it out and change the sign in front of the number. So however you remember to do it, just do it correctly, okay? Number 6, square root is like an exponent. I could have written this problem as negative 50 to the 1/2 power, okay? And negative 2 to the 1/2 power. So according to Aunt Sally, we're supposed to do exponents before we do multiplication, right? So that's why I have to simplify these radicals before we multiply. So you can't just multiply them and put square root of 100 and then say the answer is 10. Okay, a lot of kids like to do that, okay? You gotta do your little factor tree first. And there's no number out front, so I just pull the 5 out, it's negative, pull the I out, the 2 is left. Here I can't do any factor tree, but I can pull the I out, so it's a positive 2 underneath. So that's what it simplifies to. Now I can multiply. So 5i times I is 5i squared, and then radical 2 times radical 2 is radical 4. Well, that's like 5, negative 1 for the I squared, and the square root of 4 is 2. So our answer is negative 10. Okay? So if you want to multiply first, you get positive 10. But when you do it in the correct order of operations, it's actually negative 10. Okay? Questions? Making sense? Simple, right? You can do it easy. All right, now number 7. Now we have two binomials and there's no symbol between them. Okay? Now I can FOIL. First outside, inside last. Oh, why'd that happen? Come on. All right. So when there's no symbol between, no addition or subtraction, then we're going to FOIL. So when we get to number 7, we'll FOIL the fun. So for first, that's the first 2. 6 times 2. For the outside 2, that's these 2. Is negative 30i. We're multiplying what we're doing there. I is for inside 2, which are these 2. Which is positive 10i. And L is for the last 2, which are those 2. Which is negative 25i squared. Remember, I times I is I squared. When we get in a hurry, we forget to make that an I squared. Now we try to put all 3 of those together because they all are like terms if you don't make it an I squared. All right, so remember, this is like negative 25 times negative 1 because of the I squared equals negative 1. So we just change the sign there. So I get 12 plus 25 is 37. And negative 30i plus 10i is a negative 20i. So there's my complex number answer after I multiply. Questions? Okay. Number 8, we can't FOIL right away. We need to simplify. First, I've got a number in front of this radical. So whatever I pull out from underneath the radical, I got to multiply by that 2. That's what I was talking about earlier. Now these are nice because what type of numbers are these? Perfect squares, right? So I don't have to do the factor tree because I already see perfect squares. So I get 5 plus square root of 16 is 4. I multiply it by the 2. So this is an 8. Don't add it and make it a 6. That's one mistake I get. Okay? Sometimes we just forget all about the 2 and we just put a 4 there. Remember, whatever you pull out goes times whatever's there. And since it's negative, the I also comes out. No more radical on that side. On the other side, we've got a 1 minus square root of 25 is 5. And it's negative I. There's nothing left, no radical. So it looks like that. So now number 8 looks like number 7 now, right? Now we do the same thing. All right. So 5 times 1 is 5. And 5 times negative 5i is negative 25i. And 8i times 1 is 8i. And 8i times negative 5 is negative 40i squared. So that negative 40i squared becomes positive 40. So I get 5 plus 40 is 45. And negative 25 plus 8i is a negative, sorry. Negative 17i. All right. That one seemed to give a few people trouble. But now it's easy, right? Okay. Number 9. A division problem. Remember that I is equal to the square root of negative 1. So it's like having 2 times the square root of negative 1 down there. We're allowed to have a square root in the bottom? No, we're not allowed to have i's in the bottom. Same deal. So, Mr. Myers, how do I get rid of that I in the bottom? Right. Did any multiply by 2i? That's okay. Did any multiply by negative 2i? Negative 2i would be like its conjugate, I guess. But really all we need is an I, so we can get an I squared. Then we just change it to negative 2. So negative 8 times I for the top numerator. And 2i times I is 2i squared, which, again, I can make it negative 2 then. So negative 8i divided by negative 2 is a positive 4i. Questions? Okay. Cool. You guys are so smart. It's just making my job so easy. Number 10. We've got a 5i in the numerator. And we've got 2 terms in the denominator. 2 minus 3i. Okay. So Kennedy, what do I do to get rid of that I in the bottom? Right. It's 2 plus 3i. I saw a few people kept it at 2 minus 3i. Remember to change the sign. Okay, every year I get people that'll put the same thing. You know, they'll put the same, you know, they'll put it, but they'll put 2 minus 3i over 2 minus 3i. Okay, it's the opposite symbol in between. If this was -2, this would still be -2 over here. The only thing that changes is the minus to a plus or plus to a minus. Okay? So then I'll distribute. You know, a lot of times I'll put parentheses around these. You don't have to, but that just reminds me I'm going to FOIL on the bottom and in this problem distribute on top. So I got 5i times 2 is 10i. And 5i times 3i is 15i squared. On the bottom, I got 2 times 2 for first, 2 times 3i for outside, negative 3i times 2 for inside, and negative 3i times positive 3i for last. So it looks like that. I see a couple I squareds, so that negative 9 becomes positive, and that positive 15 becomes negative 15. The 6 i's also cancel. That's always going to be true. Now we call these complex conjugates. When you multiply complex conjugates, you'll just get a whole number answer. Okay? The shortcut way, if you don't want to do this middle part, is just take the 2 and square it for the 4, take the 3 and square it for the 9, and it's always going to be addition. Always addition. So, my final answer is, I like to put it in the right order, so this is the real part, a negative 15, and then the imaginary part is in the back. But if you didn't have it in that order, that's okay. And then 4 plus 9 is 13. Now at this point, we should check for a common factor between all three of them. You know, 5 goes into both of those, but not those, so there's no common factor, so we're done. But always reduce it if possible. That one makes sense? Questions? Okay, only 2 more. We got a binomial top and bottom. So Nick, what do I multiply top and bottom by?
4 minus, yeah.
Thank you. So again, the mistake I get is you'll keep these as 4 plus 3i. Okay? Change the sign. Okay, then we FOIL. Negative 7 times 4. Negative 7 times negative 3 is a positive 21. 26 times 4 is a positive 104. And 26i times negative 3i is a negative 78i squared. For the bottom, I'm just going to do the shortcut. You take the 4 and square it. You take the 3 and square it. And it's always addition between them. Your middle terms will cancel out. Your 12i and negative 12i is what you would get. All right, so we see an I squared. So that 78 ends up being a positive 78. Minus 28 is a positive 50. 21 and 104 is 125i. 16 plus 9 is 25. All done, right? Michael says no. Why not?
It's 25 and then all this.
Yeah. There's a common factor of 25 for all 3 of those, so we should divide 25 into all 3 of those. So actually it's 2 plus, what is that, 5? Over 1. You don't have to put the 1 if you don't want to. So that came out nice. at the end. Questions on that one? If you missed it, did you see what you did wrong? That's the main thing. Correct that little mistake. 100%. Come on. 60 pointer, 5 apiece. So again, should be, I'm looking for getting rid of lots of stickers because you guys are going to do so well tomorrow. All right, on these, got that big exponent. Jamie, what did we just say we have to do?
You put the 4, so you would be 66 and then divide it by 4.
Right. Why are we dividing by 4, Chris Wall?
4 different answers.
Right. There's 4 possible answers. There's only 4 possible answers. So that's why we're dividing by 4. Okay, let's go through the answers. Possibilities. When you divide by 4, you could get a remainder of 0, which means your exponent becomes a 0, and then anything to the 0 power is 1. You could have a remainder of 1, which means your problem would be I to the first power. Anything to the first power is itself. You could have a remainder of 2, which means your exponent becomes a 2. And we've been talking all week that I squared equals -1. Or you could have a remainder of 3. Okay, so you should have known these 3 anyway. Okay, the third one, just think of it as the first, it will, I to the first times I to the second equals I to the third. So I to the first is I to the second is -1. When I multiply, I get -I. Those are the 4 possible answers. Now, if you've got other numbers times it or divide it into it, you're going to have to do some more work. But this one was just an I. Now, if you're doing long division, you look for 0, 1, 0, 1, 2, or 3. If you're doing the calculator, you're looking for a whole number if there's no remainder. You're looking for a 0.25 in your answer if the remainder is 1, because that's 1/4. You're looking for a 0.5 for a remainder of 2, 2/4 is a half, and 3/4, remainder of 3 means your decimal would be 0.75 if you're using a calculator. So that's a little table that I told you to memorize. Okay? So when I go 66 divided by 4, I'll do it the old-fashioned way because I'm an old man. 6 divided by 4 is 1. 1 times 4 is 4. When I subtract, the remainder is 2, but I'm not finished. You got to bring down the other 6. Now I go 26 divided by 4 is 6 because 6 times 4 is 24, and the remainder is 2. That's what I'm looking for. So that means I could rewrite this I to the 66 is the same as I squared, which is what? -1. That's our answer. If you put that in your calculator, you're going to get 16.5. 66 divided by 4. Oops, I don't want that. You see the 0.5. Okay? Questions? You guys are doing well. Look good, feel good? You are good. Did you get the bear? Did you get the bear? Or the bear gets you? Either the hammer or the nail. Don't be a nail. All right? You're either in there or you're out of there. Get in here. Do good. You're not out there. Okay? Yeah. I know it does. okay on that?
Yeah, I've worked pretty long. When you do it on your own, you get, there's a couple of them, roll out trucks.